Chapter 6 Application of Derivatives Exercise 6.3 or 6.5 in the previous textbook. 26th question. Show that the semi-vertical angle of a right circular cone of given surface area and maximum volume is sin inverse 1 by 3. So I have shown a cone here. So let R be the radius of the base of the cone. Now we have the h, that is means the height of the cone. L be the slant height of the cone. Now we have V as the volume of the cone, that is equal to 1 by 3 pi r square h. Now S is equal to the surface area of cone, which is equal to pi r square plus pi r l. Now from the figure of cone we have L, H and R. So it's a right angle triangle. So applying the Pythagoras theorem here, we have L square is equal to H square plus R square, or L is equal to root of H square plus R square. So surface area of the cone S is given by pi r square plus pi r l. Instead of L we have H square plus R, root of H square plus R square. Substituting that, so we can write taking pi r square in with S, we have pi r into root of H square plus R square is equal to S minus pi r square. Pi r square is taken to the right side, or dividing by pi r on both sides. So we have pi r into root of H square plus R square by pi r is equal to S by pi r minus pi r square by pi r. So cancelling the terms of pi r's, we have root of H square plus R square is equal to S by pi r minus r. Now squaring on both sides, so we can write root of H square plus R square whole square is equal to S by pi r minus r whole square, or H square, root and square cancel. So H square plus R square is equal to S. By expanding the terms, so we have S square by pi square R square minus 2 R by pi r plus R square cancel. So we have H square is equal to S square by pi square R square minus 2s R and R cancel, so 2s by pi. Now we have H is equal to root of that is A square by pi square R square minus 2s by pi. Now what is volume? Volume is equal to 1 by 3 pi r square h. So V square is maximum and V is maximum. So what is V square? That is 1 by 3 pi r square h whole square, that is 1 by 9 pi square r raised to 4 h square. So instead of h square we have the equation for h, right? So substituting that here, so pi square r raised to 4 by 9 into root of h square pi square r square minus s 2s by pi whole square, root square cancelled. So pi square r raised to 4 by 9 into a square by pi square r square minus 2s by pi. Now opening the bracket, we have pi square r raised to 4 into a square by 9 pi square r square minus pi square r raised to 4 into 2s by 9 pi, cancelling the terms. So we have the remaining, that is s square r square by 9 minus the next term, that is 2s pi r raised to 4 by 9. So that is V square. Now we are finding what is d by dr of V square, that is d by dr of the given terms, that is s square r square by 9 minus 2 pi s r raised to 4 by 9. Now first d by dr of s square r square by 9, s square by 9 is a constant, into r d by dr of r square, that is 2r, minus 2 pi s by 9 is again constant, into r raised to 4, that is 4r cube d by dr. So we have 2 s square r by 9 minus 8 pi s r cube by 9, that is d by dr of v square. When d by dr of v square is equal to 0, we can write 2 s square r by 9 minus 8 pi s r cube by 9 is equal to 0, or we have 2 s square r by 9 is equal to minus 8 pi s r cube by 9 is taken to right side, is equal to 8 pi s r cube by 9. So cancelling the terms, 9, 9, 2, 8, remaining 4 is s square, etc. So we have the remaining, that is r square, r cube r, that is r square is equal to s by 4 pi. So we have got what is r square. So what is r? Then it is root of s by 4 pi. Now we are finding the second derivative, that is d square dr square of v square, that is d by dr of 2s square r by 9 minus 8 pi s r cube by 9. So we have d square r dr square of v square is equal to, first term d by dr of 2s square r by 9, that is 2s square by 9 only, minus d by dr of 8 pi s r cube by 9, that is 8 pi s by 9 is constant, into r cube d by dr, that is 3r square, or we can write 2s square by 9 minus 8 into 3, that is 24 pi s r square by 9, that is d square v square d by dr square. When r is equal to root of s by 4 pi, we are applying it in the equation of d square v square by dr square, that is 2s square by 9 minus 24 pi s by 9 into, instead of r square, that is s by 4 pi. R is equal to root s by 4 pi. So r square is equal to s by 4 pi. Cancelling 24 and 4 in the second term. So we have the remaining, that is 2s square by 9 minus 6x square by 9. So we have d square v by v square by dr square is equal to 2s square minus 6x square, that is minus 4x square by 9. 9 is the common denominator. So minus 4s square by 9, that is a negative quantity which is less than 0. So we have maximum here. So we have got maximum here at r is equal to s root of s by 4 pi. So now we will be going back to our question, that is for a semi-vertical angle. It's given that in the question, for a semi-vertical angle with of a right circular cone of given surface area and maximum volume is sine inverse 1 by 3. So we have got surface area and maximum volume here. So we want to find the semi-vertical angle is equal to sine inverse 1 by 3. So we have, for that, what is h first? That is, we have got h is equal to a root of s square by pi square r square minus 2s by pi, or from this h square is equal to s square by pi square r square minus 2s by pi. So we have got what is h square. Now what is r? That is root of s by 4 pi. So r square is equal to s by 4 pi. So we have h square and r square. Now we have the equation for h square, that is s square by pi square r square is s by 4 pi minus 2s by pi, substituting the value of r here. So we have h square is equal to, cancelling the terms s square s and pi square pi, we have 4s by pi minus 2s by pi. What is 4s minus 2s? That is 2s itself. So h square is equal to 2s by pi. So we have got h, r, etc. So we will be having the Pythagoras theorem, that is L square is equal to h square plus r square. From this L can be find out. So L square is equal to 2s by pi minus what is r square, that is s by 4 pi, or cross multiplying, we have 2s into 4 pi, that is 8s pi minus pi into s, that is s by 8 by 4 pi square. 8s by pi plus s by pi, that is 9s pi divided by 4 pi square. Cancelling pi square and pi, we have L square is equal to 9s by 4 pi, or L is equal to root of 9s by 4 pi. 9 and 4, their root are 3 and 2, right? 3 by 2 root of s by pi. So we have got L, h and r. So we have the semi-vertical angle, let it be a theta. I have marked in the figure. So what is the sine of theta? That is opposite side by hypotenuse. So we have, for an angle theta, sine theta is equal to opposite side by hypotenuse, that is sine theta is equal to, from the figure it is opposite side is r and hypotenuse is L. So r by L. So we have the values for r and L. That are the r, that is s by root of s by 4 pi, and L is equal to 3 by 2 root s by pi. Substituting that, so we have root of s by 4 pi divided by root of 3 by 2 s by 4 pi, or root of 9 by 4 s by pi, both are equal. So cancelling the terms, we had 4 pi, root 4 pi, root 4 pi, and so we have root s by root 9s. Again cancelling root s, we have 1 by root 9. What is 1 by root 9? That is 1 by 3. So we have got sine theta is equal to 1 by 3, or theta is equal to sine inverse 1 by 3. So for a given surface area and volume of a right circular cone is maximum when theta, the angular when the semi-vertical angular theta is equal to sine inverse 1 by 3. Hence proved. Chapter 6, Application of Derivatives, Exercise 6.3 or 6.5 in the previous textbook. 27th question, that is, choose the correct answer in question 27 and 29. 27th question, the point on the curves x square is equal to 2y, which is nearest to the point 0, 5 is a 2 root 2 4, b 2 root 2 0, c 0 0, and d 2 2. Answer, let d be the distance of the point xy on x square is equal to 2y from the point 0, 5. Now we have d is equal to root of x minus 0 whole square plus y minus 5 whole square. So what is root of x minus 0 whole square? Root of that is x square plus y minus 5 whole square. We are expanding the term, that is y square minus 10y plus 25, or we can write root of x square plus y square minus 10y plus 25. So what is x square? It's given in the question, that is 2y. Substituting for x square, that is 2y plus y square minus 10y plus 25, 2y and minus 10y, that is minus 8y, right? So y root of y square minus 8y plus 25. We have d is equal to root of y square minus 8y plus 25, or d square is equal to y square minus 8y plus 25. Root and square is cancelled here. So y square minus 8y plus 25. Let d square be the function. So we can write d square is equal to f of y here. So f of y is equal to y square minus 8y plus 25. What is f dash of y? That is d by dy of y square plus 8y plus 25. That is d by dy of y square, that is 2y, d by dy of minus 8y, that is minus 8, d by dy of 25, 0. So we have when f dash of y is equal to 0, we have 2y minus 8 is equal to 0. From this, y is equal to 8 by 2, or the value for y is 4. So we have y is equal to 4. So when y is equal to 4, we have the equation, that is x square is equal to 2y. So x square is equal to 2 into 4, that is 8. Or if x square is equal to 8, we can write x is equal to root of 8. What is root of 8? That is 2 root 2. So we have the values for x is equal to 2 root 2 and y is equal to 4. So the points will be 2 root 2 and 4. So we have from the question, we have the option A as the answer. Moving on to the next question, that is 28th question. We have, for all real values of x, the minimum value of 1 minus x plus x square by 1 plus x plus x square is 0, b1, c3, d1 by 3. So we have the function f of x is equal to 1 minus x plus x square divided by 1 plus x square. So we are applying what is f dash of x, that is d by dx of 1 minus x plus x square divided by 1 plus x square. We are applying the division rule here, that is d by dx of m by n. That is equal to n into dm by dx minus m into dn by dx by n square. So we are applying that rule here. So we have f dash of x is equal to 1 plus x square into d by dx of 1 minus x plus x square minus 1 minus x plus x square into d by dx of 1 plus x square divided by 1 plus x square whole square. So by solving, we have 1 plus x square into d by dx of 1 minus x plus x square. We have the remaining, that is minus 1 plus 2x minus 1 minus x plus x square into d by dx of 1 plus x square, that is 1 plus 2x whole divided by 1 plus x square whole square. Now we have f dash of x, which is equal to, we are opening the brackets for each and every terms. So we have 1 is multiplied with every terms of second, and similarly x and x square is again multiplied. So we have the result, that is minus 1 plus 2x minus x plus 2x square minus x square plus 2x cube minus the next two brackets, that is 1 plus 2x minus x minus 2x square plus x square plus 2x cube whole divided by 1 plus x square whole square. Now removing the bracket and multiplying negative into the second bracket. So we have minus 1 plus 2x minus x plus 2x square minus x square plus 2x cube minus 1 minus 2x plus x plus 2x square minus x square plus minus 2x cube whole divided by 1 plus x square whole square. So by cancelling and solving the numerator, we have the remaining, that is minus 2 plus 2x square plus 2x square, that is plus 4x square. So the minus x square, that is minus 2x square divided by 1 plus x square whole square, or we have minus 2 plus 4x square and minus 2x square, that is plus 2x square divided by 1 plus x square whole square. So 2 is taken common from numerator, so we have 2 into x square minus 1 divided by 1 plus x plus x square whole square. What is x square minus 1? That is x plus 1 into x minus 1. So applying that here, f dash of x is equal to 2 into x plus 1 into x minus 1 divided by 1 plus x square whole square. When f dash of x is equal to 0, we have 2x into x plus 1 into x minus 1 divided by 1 plus x square whole square is equal to 0. When 1 plus x square whole square is taken to the other side, that is always 0. So 2 into x plus 1 into x minus 1 equal to 0. From this we can write x is equal to minus 1 or x is equal to plus 1. So we have two values for x, minus 1 and plus 1. Now what is f double dash of x? That is d by dx of f dash of x, that is 2 into x square minus 1 whole divided by 1 plus x square whole square. Or we are applying the again division rule here. So we have 1 plus x square whole square into d by dx of 2 into x square minus 1 minus 2 into x square minus 1 into d by dx of 1 plus x square whole square divided by 1 plus x square whole square. Or we can write 1 plus x square into d by dx of 2 into x square minus 1, that is 2 into 2x minus 2 into x square minus 1 into d by dx of 1 plus x square whole square, that is 2 into 1 plus x square into d by dx of 1 plus x square, that is 1 plus 2x divided by 1 plus x square whole raised to 4. So opening the bracket for the first terms, we have 4x into 1 plus x square whole square minus, again for the second term, so we have 2 into 2 at outside, that is 4 into x square minus 1 into 1 plus x square into 1 plus 2x divided by 1 plus x square whole raised to 4. So when we solve this with this long method, so when we solve this, we have f dash of x is equal to 4 into 1 plus 3x minus x cube divided by 1 plus x square whole cube. So at x equal to minus 1, we are applying the value of minus 1 in the equation of f dash of x, that is 4 into 1 plus 3x minus x cube divided by 1 plus x square whole cube. So if we apply minus 1, we will be getting minus 4 by 1, which is less than 0. So negative quantity, so we have maximum here. Similarly, when at f double dash of x equal to at x equal to plus 1, we have 4 into 1 plus 3 minus 1 divided by 1 plus 1 whole cube, that is 4 into 3 by 27, or we will be getting the answer 4 by 9. That is a positive quantity which is greater than 0. So we have minimum at x equal to 1. So we have got minimum value at x equal to 1. So what is f of 1? So we are going back to our question. We want to find the minimum value. So what is f of x? That is 1 minus x square divided by 1 plus x square. So f of 1 is equal to 1 minus 1 plus 1 divided by 1 plus 1 plus 1. So by solving, it is 1 by 3. So we have minimum at f of 1 is equal to 1 by 3. So minimum value is 1 by 3. That is option D. Chapter 6, Application of Derivatives, exercise 6.3 or 6.5 in the previous textbook. Question number 29, that is the maximum value of x into x minus 1 plus 1 whole raised to 1 by 3, 0 less than or equal to x less than or equal to 1 is, first a is equal to 1 by 3 whole raised to 1 by 3, at b is equal to 1 by 2, c 1, d 0. So at f of x is equal to x into x minus 1 plus 1 whole raised to 1 by 3, where x belongs to the interval 0 to 1. That is 0 less than or equal to x less than or equal to 1. So x belongs to the interval 0 to 1. Now what is f dash of x? That is d by dx of x into x minus 1 plus 1 whole raised to 1 by 3. Or we are opening the bracket. So we have d by dx of x into x, that is x square minus x into 1, minus 1, that is x square minus x plus 1 whole raised to 1 by 3. Or d by dx of that is 1 by 3 into x square minus x plus 1 whole raised to 1 by 3 minus 1 into d by dx of x square minus x plus 1, or 1 by 3 into x square minus x plus 1 whole raised to minus 2 by 3 into d by dx of x square minus x plus 1, that is 2x minus 1. So we have f dash of x is equal to 1 by 3 into, that is second term, that is x square minus x plus 1 whole raised to minus 2 by 3. That comes to the denominator, that is x square minus x plus 1 whole raised to 2 by 3. And the remaining, that is 2x minus 1 at the numerator. So we have 2x minus 1 by 3 into x square minus x plus 1 whole raised to 2 by 3. So when f dash of x is equal to 0, we can write 2x minus 1 by 3 into x square plus minus x plus 1 whole raised to 2 by 3 is equal to 0. When the denominator term comes to the right side, when multiplied with 0, we have 0 there. So we have only 2x minus 1 equal to 0 now. So from this, x is equal to 1 by 2. So if x is equal to 1 by 2, does that belongs to the interval 0 to 1? Yes, it belongs to the interval 0 to 1. So we have three values for x, that is 0, 1 by 2 and 1. So we have f of x is equal to x into x minus 1 plus 1 whole raised to 1 by 3, or x square minus x plus 1 whole raised to 1 by 3. So in the question we want to find the maximum value of x, right? So we are applying each and every value of x in the equation of f of x. So we have f of x is equal to first at x equal to 0, we have f of 0, that is 0 square minus 0 plus 1 whole raised to 1 by 3, that is 1 raised to 1 by 3, or f of 0 is equal to 1. Now at x equal to next, that is 1 by 2, that is f of 1 by 2, that is 1 by 2 whole square minus 1 by 2 plus 1 whole raised to 1 by 3. So when we solve that, that we will be getting 1 by 2 square, that is 3 by 4 whole raised to 1 by 3. So we have 3 by 4 is something point raised to, that is 0.7 something, right? So it's 0.7 whole raised to 1 by 3. Now at x equal to the next, that is at x equal to 1, we have f of 1 is equal to 1 minus 1 square minus 1 plus 1 whole raised to 1 by 3, that is 1 raised to 1 by 3, that is 1 itself. So we have f of 0 is equal to 1 and f of 1 is equal to 1. So we have the maximum values at f of 0 equal to 1 and f of 1 equal to 1. So at x equal to maximum value is at x equal to 0 and x at x equal to 1. So the maximum value of the given function is 1, option C.